All right, so now we're going to put a bunch of stuff together, and we are going to be able to convert from hydronium concentration or hydrogen ion concentration to hydroxide ion concentration to pH and pOH and all around the circle. So the key things to remember is that there's two key concepts, which is that the Kw, so the ionization constant of water, is equal to the concentration of hydrogen or hydronium times the concentration of hydroxide, and that at 25 degrees Celsius, which we're going to do everything at 25 degrees Celsius, we can put in that the Kw value is 1.00 times 10 to the negative 14. The other thing that we've talked about is that to go between like pH and pOH is that they have to add to 14 at 25 degrees Celsius. So we call this pKw, and it's equal to pH plus pOH, and at 25 degrees Celsius, we can say that the pKw is 14. So then what you're going to do is you're going to be maybe starting at something like hydrogen ion concentration or hydronium ion concentration and asked what is the pOH. And so you'd have to go from hydronium to pH to pOH, or you could go from hydronium to hydroxide to pOH using those calculations we just talked about. So Kw, which goes between hydronium and hydroxide, or pKa, which is going between pH and pOH, or within pH and concentration of your ion, you're either going to be using 10 to the negative pH or the negative log of the concentration. All right, so what is this going to look like? Well, let's start with a question. So let's start with something that has asked you to find the hydroxide ion concentration when the pH is 6.330. Now, like I was saying, we are starting here. And you could either go from pH to pOH and then pOH up to hydroxide, or you could go pH to hydronium or hydrogen ion concentration to hydroxide ion concentration. I find that when I can go between pH and pOH, I'll always choose that route because it's a simple addition to 14. So let's start there. So we're going to go from pH to pOH. So to find the pOH, you're going to take this concentration that pH and pOH adds to give you 14, and you're going to say to solve for the pOH, you're going to do 14 minus the pH. So we're going to do 14, and they just give you lots of precision so that the conversion doesn't affect your precision, right? So then we're going to subtract that pH of 6.330, and that's going to give me a pOH of 14 minus 6.33, 7.67, and I'm going to throw the 0 on there to maintain sig figs. So when you're subtracting, I had 3 decimal places minus 3 decimal places, so I'm going to keep 3 decimal places. And now I'm going to go from pOH up to hydroxide ion concentration. So it's going to be that the hydroxide ion concentration is equal to 10 to the negative pOH. So in there, I'm going to put 10 to the negative 7.670, and I get 10 to the negative 7.67. And now that's going to give me, now I've got 3 decimal places, so I have to answer with 3 sig figs. My calculator is only giving me 2, so I'm going to change my calculator into scientific notation, and I can answer as 2.14 times 10 to the negative 8. Because I'm solving for a concentration, I'm going to put the units of moles per liter or molar. All right, let's keep going. This time we're going to start with the hydroxide ion concentration, and they want us to go to pH. So we are now starting here, and we need to go to pH. So we can either go hydroxide to pOH to pH, or we could go hydroxide to hydronium to pH. Like I said, I always try to go from pH to pOH when I can because it's a simpler conversion. So the first thing I'm going to do is go from hydroxide to pOH. To find the pOH, it is always the negative log of the hydroxide ion concentration. So it's going to be negative log of 5.00 times 10 to the negative 4. Which if I plug that in, I get negative log of 5 times 10 to the negative 4. My calculator is still in scientific notation mode. I need to take it out of that. Okay, and then I get 3 points. Now, I have 3 sig figs in my concentration, so I'm going to put 3 decimal places in my pOH. So I get 3.301, but I'm going to do ... because if I use this number in a future calculation, I'm going to use it unrounded. So now, to calculate the pH, I'm going to say that it's 14 minus the pOH. So it's going to be 14 minus the 3.301 ... but I'm going to answer to 3 decimal places. So I'm going to do 14 minus the answer that's in my calculator, oops, which just screwed up. So I'm going to go negative log 5 times 10 to the negative 4. It's often why I store and recall, just in case I screw something up when I'm plugging things in. 14 minus that answer. And I get, again, to 3 decimal places because I'm subtracting, 10.6989. So 10.699 would be my pH. Now, something that I didn't ask you here, but it would be a good thing to be kind of thinking of is, whether these solutions are acidic and basic. You can tell at any point in time. So with this first question, I had a pH that was less than 7, so I know that this guy is acidic. Right? This one, hydroxide ion concentration, doesn't mean as much to me as pH and pOH. As soon as I got to that pH of 10.699, then I know that this guy is basic. But just some skills that you don't want to lose along the way, right? Determining if something is acidic or basic. Okay, then let's do this last one here. Find the pOH if the hydronium concentration is, or here they've actually written hydrogen because it is interchangeable. You will find that a lot of places use the simplified version of hydrogen. If we're being proper, we would use hydronium, but they are interchangeable. So I have to go from hydrogen to pOH. I can go hydrogen to hydroxide to pOH, or I could do hydrogen to pH to pOH. And again, it's your choice. I love going through pH and pOH if I can, though. So first thing I'm going to do is find pH. pH is going to equal negative log of the concentration, which I was really good at writing the formula, and all of a sudden I've stopped. So of the concentration of hydrogen. So I'm going to plug in negative log of 0.03. So that's going to be negative log of 0.03, which gives me a pH of 1 point. Now this is 2 sig figs, so 2 decimal places, so 1.52 ... And then I'm going to find the pOH by doing 14 minus the pH, third decimal. So it's going to be 14 minus 1.52. And then I am subtracting, so I'm going to maintain precision. So I'm going to do 14 minus that answer, and I get 12.4, and then my 7 rounds to an 8. So again, if I'm determining if this is acidic or basic, my go-to is always to look at the pH. The pH is less than 7. That makes this acidic, but it's also because the pOH is greater than 7. Awesome. So hopefully you're feeling confident converting between those. Go and practice a bunch before we go to the next lesson.